All right, let's just jump right in. We're living in a pretty wild time, right? You've got AI that can give you an answer to literally anything in seconds. But here's the catch. It's never been harder to know if that answer is actually right. So today, we're going to talk about how to navigate this new world, not just by getting answers, but by thinking. So let's dive into the core of it. The biggest selling point of AI is also its biggest trap. We ask a question, we get a response instantly. But what is that response really? What are we actually getting? And here's why. AI isn't really built to tell you the truth. It's built to tell you what's popular. It's like a super fast intern that just skims the entire internet and brings back whatever it saw the most. It's not checking sources, it's counting mentions. And this slide right here really gets to the heart of it. On one hand, you have the popular answer. It's everywhere, it's easy, it's usually just the same shallow idea copy-pasted 1,000 times. But the correct answer, oh, that's a different beast entirely. That takes work. That means you gotta roll up your sleeves and dig for the original data. This is the world that AI is swimming in. It's called data noise. Imagine trying to find one original first edition book in a library filled with 300,000 bad photocopies of it. That's what AI is up against. And more often than not, it just grabs the copy that's on top of the pile. But here's the real kicker. The danger here isn't some abstract idea about misinformation in the world. No, it's way more personal than that. It's about what happens when you're the one who hits share. Because every single time you pass along something you haven't checked, you're putting your own name on it. You're basically vouching for it. And that means your reputation, your credibility, that's what's on the line. Okay, so if the internet is full of noise, how do we find the signal? Well, let's take a look at a system that has a built-in junk filter, one that's been working for hundreds of years: science. Now that sounds intense, right? Enemies? But it's not about people hating each other. It's about a deep, professional commitment to tearing ideas apart to see if they can survive. It's the ultimate quality control. Say, in the scientific community, everybody's job is to be the toughest critic of everybody else's work. They poke, they prod, they look for every single flaw. And this process, this constant challenge, is what forces ideas to become stronger, sharper, and way more accurate. And this is what that process actually looks like. A paper doesn't just get published. No way. First, an editor gives it a quick look. Then it's sent to a handful of other experts in the field whose job is to actively try to break it. The author then has to defend every single point. Only if it survives that trial by fire does it ever see the light of day. So finding verified info? That's a huge first step. But to really get ahead in this new world, you have to go deeper. It's not enough to just know facts anymore. You have to understand the why behind them. Rote memorization is a dead-end street. Let me give you a wild example. Your blood's normal pH is about 7.4. If it drops to 7.35, you could fall into a coma. That's a change of 0.05. It seems like nothing, right? A rounding error. But when you understand the why, you see the incredible power of first principles. The whole explanation comes down to these tiny little biological workers called enzymes. They're proteins, and they do pretty much all the important work inside our cells. And here's the crucial thing you need to know about enzymes. Their shape is everything. Their function depends entirely on this super complex folded 3D structure. And that structure is held together by these incredibly fragile little electrical bonds. So when your blood's pH changes, even by that tiny 0.05, it completely messes with those electrical charges. The bonds break, and that perfectly folded protein just unravels. It unfolds like a cheap suit. And once that shape is gone, poof, the enzyme is useless. It can't do its job anymore. The biological assembly line it was running just grinds to a halt. Now multiply that by millions of processes failing at once, and the whole system starts to shut down. That's why that tiny number is a matter of life and death. And see, that kind of deep understanding, connecting the dots from pH to electrical bonds to system failure, that's what separates us from the machines. An AI can spit out the fact, but truly understanding the principle, that's a human skill. And honestly, it's becoming the only skill that really matters. The era of just being an executor is kind of coming to an end. Jobs where you just memorize stuff, follow instructions, or just add a little polish to make things look good on the surface. AI can do that now, and it can do it faster.
The future really belongs to the thinkers. It belongs to people who can ask tough questions, who challenge the way things are done, and who can connect those fundamental principles to solve brand new, complex problems that AI can't even see yet.
I love this line because it's so true. It's easy to be a problem namer, right? Anybody can point at something and say, that's broken. It takes zero effort. But to be a problem solver, to actually be the person who can fix it, that's where the real value is.
So, at the end of the day, what's the big takeaway? We can all complain about the data noise and the junk AI gives us. Or we can decide to be the ones who build real understanding, who check our sources, and who, as this beautiful saying goes, decide to light a candle instead of just cursing the darkness.